Let's let the fun continue. We're off into properties of the trigonometric functions. So we can talk about, just like with any functions, domain and range. So the domain of the sine function is the set of all real numbers. The domain of the cosine function is the set of all real numbers. Do you know why? Remember, the sine is y, cosine's x. Well, can't x and y be any real number? And so remember that. The domain of the sine, the domain of the cosines, all real numbers. The domain of the tangent function is the set of all real numbers except odd integer multiples of pi over 2, or 90 degrees. The domain of the secant function is the set of all real numbers except odd multiples. So the tangent and the secant have the same domain, any value except odd integer multiples of pi over 2. Do you know why? Remember that the tangent was y over x and the secant was 1 over x, so we worried about the denominators when they were 0. And if you notice, that would be at pi over 2, okay, where our x is 0. That would happen again at 3 pi over 2, and that's why it says odd integers. So guess what? It happened once again at 5 pi over 2, 7 pi over 2, and so on. All right, the cotangent and cosecant, their domains go together. All real numbers except integer multiples of pi, because this is where y equals 0. So where y equals 0 would be at pi, and then it just says multiples of pi. So in other words, 2 pi, 3 pi, 4 pi, 5 pi. I like pi. Okay, so recall that we have this point, any point on the unit circle, and it corresponds to a particular angle. And if we're on the unit circle, then we know that our x values stay between -1 and 1, and our y values stay between -1 and 1. So therefore, I can just simply plug in my x as my cosine, my y is my sine, and that gives me my range of my cosine and sine values, functions. All right, the same thing with cosecant and secant. Remember, we have to worry about the multiples of pi and then pi over 2. So as long as we stay less than or equal to -1 or greater than equal to 1, for the same for both of these, so we're not dividing by 0. Tangent, remember, is y over x, cotangent's x over y. These can be any real numbers, so their range, meaning their output, remember that's what the range is the output, would be all real numbers. So we have all the domains, all the ranges. A function is called periodic if there's a positive number that whenever theta is in the domain, so is theta plus this positive number. Okay, so in other words, this is saying that I add a number to my angle, but I end back at the same point. Okay, that's the important part. So these periodic properties are nice because I can see that the sine of theta plus 2 pi. So no matter where I am, let's just start at 0 because that would be easy. If I go 2 pi all the way back around, I'm back at the same point. Even if I'm at pi over 2, I go all the way around, I'm back at the same point. So this is saying the period, if I go 2 pi for sine, and of course cosine being the same, then if I add 2 pi, I'm back at the same spot. Works the same for cosecant and secant, because remember they're related to 1 over y and 1 over x. Now notice the tangent and cotangent. So if I start here, the tangent is 0 over 1. Well, where does that happen again? Which equals 0. If I travel along these points, the only way that's going to happen again is I hit here at pi. And so that's why the period for the tangent and the same for the cotangent, I get undefined both spots, the period is pi. So all of this is saying is if you're at a point and you go around and round, and you end back up at that same point, that could happen based off of these period properties. Okay, so for example, I want to figure out how to find the exact value using periodic properties. Now, one kind of hint here definitely is, I'm looking at colors, is I don't know, we haven't done anything with a 17 pi over 4. So I need to figure out how could I figure, where is 17 pi over 4? Now, I do this two different ways. I tend to be okay with this first way. I think a lot of students don't like this way, and I know why, is because you guys don't like fractions. But what I'm going to do is I'm going to try to figure out the 17 pi over 4. How many times have I gone a period? A period's 2 pi. Well, what I do is I look at my denominator and I say that 4 will go into 17 4 times, right? Because 4 times 4 is 16. So I would have 4 pi, and then what's left over? Well, 17 minus 16 would be 1, or 1 pi over 4. Now you could convince yourself, because you could get common denominators, right? Because what this is this is 16 pi over 4 plus pi over 4, which gives me 17 pi over 4. And this is just how I do these to separate them. Well, I know the period for the sine is 2 pi, so I've gone around the circle twice. Okay, so I've gone once around is 2 pi, again around another 2 pi, so that's 4 pi. So I ignore that, and that is actually what I'm looking for. And if you remember the few lectures, oops, I put a 3. If you remember a few lectures ago, that was the square root of 2 over 2. Okay, that we found the sine of pi over 4. All right, so I break apart the fraction. A lot of students don't like that way, and again, I know why, it's because of the fractions. But that's all I'm doing, is I'm trying to find one piece that's going to actually give me the period that I can just ignore, because I've just gone around and round. So in other words, I'm here, and I've gone around 2 pi, 4 pi, okay? So I'm back where I started from. All right, if you don't like that way, then what you do is you change your radians into degrees. So 17 pi over 4 times 180 over pi. Okay, and of course takes a calculator. So if I do this, I get 4 goes into 180, 45, 45 times 17 is 765. Now from here, what I do is I subtract out 360, because that would take me all the way around, right? So if I subtract out 360, I get 405. Well, I subtract out another 360. If I subtract out 360, guess what I get? The pi over 4, the 45 degrees. Some students just like this way better, and again, that's fine. I don't care which way you use, because they're used to dealing with degrees and going all the way around 360. But if you use this approach, then it gets where you remember that 2 pi is the period, okay, which is the same as 360 degrees. And you're trying to figure out if you've gone around and around twice, and then you go pi over 4, you're back at pi over 4. All right, let's try another one. Cosine of 5 pi. So if I go all the way around, I'm at 2. So once is 2 pi. I go all the way around again, would be 4 pi. So I've gone around twice. And so all I need now is to go another pi. So that's what I've done, is I've broken this down into 4 pi plus pi, and by periodic properties, that's just simply pi. And do you remember that value? So if I'm here at this point, I want to know the x value. So that's -1.10, and thus that would be -1. Okay, moving right along. I have a 5 pi over 4. Once again, I'll do this two different ways. So the tangent of 5 pi over 4, I see how many times will 4 go into 5, and it'll only go once. So 1 pi over 4. And then what do I have left? Well, I have 4 pi over 4, right? Because of adding these now, I can see that would give me 5 pi over 4. So all I'm doing is splitting this into my properties. And so from here, I can see that the 4's cancel. And remember, the period of the tangent is pi. So since that's the period by periodic properties, we ignore that because we just went around a period. And we find the tangent of pi over 4, which if you remember is the square root of 2 over 2 divided by square root of 2 over 2, which was 1. Okay, once again, if you don't, this is another way. If you don't like that way, turn this into degrees. So 5 pi over 4 times 180 over pi, and you should get 225 degrees. Remember, the period for the tangent is pi, or 180. So if I subtract 180, then I'm just simply finding the tangent of 45 degrees. Okay? All right, so let's stop. Let's make this one a short one because I'm going to go into something different next, and I'll see you at the next lecture.